My name is Shay Keinan. I'm a software developer at 500 Tech. I have two passions in life, front-end development and 3D. And now, with the use of ReactVR, I can enjoy them both. Today, I'm here to talk to you about ReactVR. We will start with the basic concepts of virtual reality, discuss the advantage of 3D in web browsers, and learn how to get started. By the end of this talk, you will know what ReactVR can do and how to do it. Virtual reality is being used in many industries. Besides games, VR is being used in many fields. For example, medicine, education, and movies. Because of its ability to immerse you in a scene, the possibilities are endless. Before diving into code, I want to talk to you about virtual reality concepts, things that we, as developers, must know if we want to build a virtual reality application. So what is virtual reality in a nutshell? Virtual reality is made up of two things: stereoscopic imaging and movement tracking. Let's look at these two images. Are they identical? They seem to be identical, but if you look closely, you can see a difference. I have highlighted a difference for you. Notice the figure in the background on the right? So stereoscopic images are based on how the human brain works. It takes two images that show the same content, but from a slightly different point of view. The offset of these images corresponds to the distance between our eyes. This distance is called interpupillary distance, IPD for short. In this way, we simulate the way we see the world naturally, and it gives us the perception of 3D depth. Headset lenses are an integral part of the virtual reality experience. Why do we use headset lenses? Because they position the images on the screen at the exact distance that they need to be to get the desired effect. VR lenses are thick, so they cause a distortion. The square that you see on the left looks caved in through the lenses. The outcome looks something like what we see on the right. To compensate for this, we give images that are rounded out. On the left, you can see a compensated image before the lenses, and on the right is the final desired image. So to sum up stereoscopic imaging, by showing two slightly different images to each eye, using special lenses, we get the effect of depth. Besides stereoscopic imaging, the second thing we need to complete the illusion of virtual space is to track the movement of our body. All VR devices track head movement, so we can look around. Some devices, the more expensive ones, track body movements, so we can move around. Of course, the more tracking sensors that you have, the better the illusion of reality. On April this year, Facebook announced the launch of ReactVR, a new JavaScript framework based on 3.js and React Native. ReactVR allows developers to build virtual reality experiences with the help of JavaScript. As the name implies, ReactVR uses the same concepts as Facebook's existing React framework. Just like with React for standard web apps, VR developers can now use the same declarative model to write apps for their 360-degree experiences. So, how many of you have experience in building React applications? Raise your hands, please. Okay, almost everyone. So you guys will find it very easy to build React VR applications. Just like in animation, VR apps need to be rendered at 60 frames per second. React Native have solved this issue already, and that's it. So it's important to know that React VR is based on React Native and 3.js. Most of the components that we use are React Native components. and the 3D rendering engine is the 3JS rendering engine. For those of you who are not familiar with 3JS, 3JS is a cross-browser JavaScript library used for displaying animated 3D graphics. Let's look at some 3JS examples from the web. So all of this is done in the web, 3D in the web. So that was pretty awesome, right? 3D in the web. It's not 3D Max. You don't need to install some special application. Everything is in the web. So let's get started. We'll begin by installing the tool we need. First, we will install ReactVR CLI. Next, we are going to initialize the project. This will install all of the dependencies that we need to run the project. Facebook already created a very basic Hello World application. They called it Welcome to VR. So if everything went well, you should see the next screen when you open the browser. So we have a basic scene with a panoramic image of a room. And in front of us, there is a text component with the word hello. After the init, we get the following file structure. There is the static assets folder. And if we want to add 3D models, textures, materials, images, this is the right place. The entry point for the application is the index.vr.js file. And you see that there is a folder called VR. In that folder, there is always a file called client.js. Is used for the application configuration, all of the VR stuff. So index.vr.js, this is the entry point for our application. We have a basic React component that contains 2 children, pano for the panoramic image of the room that we saw, and text for the word hello. On the bottom, we register the Welcome to VR component, just like in React. So let's begin building our own application. The app that we are going to build together will present the solar system planets. This is what the application is going to look like. We can see a planet with some text. There is a menu on the right to change to another planet, and some additional info about the planet on our left. So here's the link to the application. You can try it right now. It's just bit.ly/solarvr. Try it with your phones and see that everything works well. At the end of this talk, I will also give you a link to the project itself. You are free to use it. Okay, so again, bit.ly/solarvr. And let's move on. To know where to place objects and how to move around the scene, we need to be familiar with the coordinate system. The coordinate system is the same as OpenGL coordinates, meaning that y positive is up, and we use the right-hand rule. Okay, so this is the y-axis, and this is a positive rotation for y. This is a negative rotation. Okay, this is the right-hand rule. We can apply transformation on any component, just like we do with CSS. The syntax is a bit different than classic CSS, but you should be familiar to those who code in React Native. If I want to place an object anywhere other than 0, 0, 0, I use translate. If I want to change its size, I use scale. And if I want to rotate it along a certain axis, I use rotate, just like in CSS. Just like React Native, ReactVR provides a set of basic primitives used to construct user interface. This is a powerful feature. Developers can use the same styling and layout system across web, React Native, and VR. which opens the doors to directly sharing layout styles across these platforms. View is the most fundamental component for building a UI. View is a container that supports layout with Flexbox, style, and touch handling. View maps directly to the native Vue equivalent on whatever platform React Native is running on. Whether that is a UI view, a div, Android view, etc. View is designed to be nested inside other views and can have 0 to many children of any type. Text is a React component for displaying text. Text supports nesting and styling as well. Image is a React component for displaying different types of images. Keep in mind that you must manually specify the dimensions of your image. Image dimensions are specified in meters, and it is not possible to predict the intended dimensions from the pixel width and height of the actual image. So let's go back to our solar system app and add a Pano component. Pano is a sphere of 1,000 meters with a center located at the local transform origin. Usually, it's 0, 0, 0. Panos are images projected onto a sphere that fully surrounds the viewer. You can create Pano-compatible images by using a special 360 camera or even with your phone. CubeMap images are also supported in Pano. You can specify a source URL as an array of 6 individual images. So let's add a Pano component to our index.vr.js. We need to provide an asset to the source property. Note that we are using a utility from ReactVR called asset. This allows us to load assets directly from the static assets folder. Note that this is not just any JPEG, but rather one that supports 3D. So this is my JPEG. Let's see what it looks like in 3D. This is the result. If you see something, this is the result. Our sphere is the cosmos, and the image surrounds us. So that was the Pano component. Let's talk about the Flexbox layout system. ReactVR makes use of a Flexbox style layout algorithm to automatically position components and their children. The library used is CSS layout. The syntax is more or less identical to the web Flexbox. As you can imagine, using Flexbox to lay out content on a 2D plane is not optimal for a 3D experience. So it's common practice to lay out the content on cylindrical plane. This will give us a 2.5D feel. Let's create the solar system application header, just like in React. Here is the declaration. We have a stateless component that gets a string, the name of the current planet that we are viewing, and returns a new view with 2 texts inside, a title and a subtitle. Same syntax as in React and React Native. This is the resulting header. You can see the title and the subtitle, the name of the current planet that we will change soon. In our application, I created a menu to navigate between planets. This is our menu. It's basically a view that contains other views, 1 per planet, 1 view per planet. Notice the billboarding property. Billboarding is a Boolean property for controlling the view rotation towards the screen, meaning that when billboarding is on, the view will always face the viewer. Let me show you. So here we have 2 views. The one on the left is always facing us. So that was billboarding for the view component. So this is our menu, a view with 9 views. one for each planet. So we built a menu for navigating among the planets. Now we need to make it clickable. In VR, we interact with objects in a different way than the web. We don't necessarily click on something. It may be enough that we look at an object for a significant amount of time to trigger an event. Other than looking, we can also press a controller to trigger a reaction. To make our scene interactable, we are going to use React's VR button, a helper component that manages the interaction state machine. By default, a VR button has no appearance and will only act as a wrapper to capture events, but it can be styled in the same ways as a view. When pressing a button in our menu, the handle click function will save the planet name in the current planet variable. So let's take a look at our menu again. Now, when we press a button, we are updating the current planet variable in our state. And as a result, the header component updates. Next, I want to talk about loading models. There are many types of model formats available out there. OBJ, STL, Collada. They may come with a built-in animation. They may come with material and with texture. At the moment, React VR supports the wavefront OBJ file format only. And if you want to extend it, I will show you a way to do it later on. Under the static assets folder, I have created a folder for models and a folder for textures. React VR provides a component for loading models. The name of this component called model. So let's load Earth. Here is our planet declaration. You can see there is a property called lit. The lit property specifies if the model will be affected by lights. The model's ability to define a style enables us to apply different transformations, such as scaling, rotating, and translating. So we can scale the planet, move it to another place, and rotate it if we want. So here is an example to a dynamic loading. The path is just changing, not just Earth, but rather any planet, the current planet. So here is the loaded model. By changing the current planet, we are causing a new model to load every time. To make our scene more interesting, we can add animation to objects and layouts. There are two ways to create animations in React VR: using the animated library or manually with request animation frame. This is an example of request animation frame. What I want to do here is rotate a planet. The rotate function in this example is called in a loop, hopefully at least 60 frames per second. On each call, we are advancing the rotation by a delta. This is the result. We can see the planet rotating. And if we switch planets, the new model will still rotate around itself. Let's see an example of how to use the animated library for animations. When a button is pressed, we want to make it look like it bounces a bit. And also when a planet appears, we'll give it a nice little bounce. In the animated library, this effect is called spring. So let's look at the bounce effect. It's pretty easy if you use the animated library. If React VR doesn't support a feature that you need, you can build it yourself using native modules. A lot of stuff that exists in Tree.js has not yet been implemented in React VR. For example, there are dozens of geometries in Tree.js, of which only sphere, box, and cylinder exist in React VR. This tetrahedron geometry is supported in 3JS, but not in ReactVR. So let's create a native module. Let's extend it for React. I need to do two things. First, I create a module, and in its constructor, I receive the 3JS scene. From this point, the 3JS scene is open to me. The rows within the add function, for example, are all 3JS coding. I define a tetrahedron geometry, a mesh Lambert material, and a new mesh that I'm adding to the actual 3JS scene. The second thing I have to do is go to my client.js file and place my native module in the native modules array. I also make sure that my module is rendered. Down there, there is the render loop of 3JS. So in each iteration, I make sure that also my module is rendered. So here is my tetrahedron geometry in ReactVR. These tetrahedrons are going to be my asteroids. Here is the final application. We are inside a panel where we loaded an image of stars. We see the header with two texts inside. Below, that is a loaded model, the planet surrounded by asteroids that we created by using native modules. On the right is a menu. A click on the menu switches to a different planet with a bounce. The menu button also has a spring to it. And on our left, this is the info view. Both the menu and the info have a billboard property that is on, and as a result, those views are always face us. The entire project is posted here. Feel free to use it. It's bit.ly/solarVRapp. ReactVR is relatively new. Time will tell if the community will adopt it. ReactVR is a quick and easy way to build a 3D application. I'll be happy if you share your applications and insights with me. That's my email up there. If you have any questions, I'll be just outside after this. Thank you very much, and enjoy the break.